Stangibelisco here. I would like to explain um, a concept that I thought up and actually put into practice once. I call it open hardline. And what it basically is, um, is a section of copper tubing, shown here as the gray circle, with a length of wire running down inside it, and that wire ideally should be supported by spacers such as plastic discs or something like that to keep it in the center, but it doesn't have to be as long as it's insulated and as long as you don't run too much power. The characteristic impedance of a coaxial line with an air dielectric, which is what this would be, is given by this formula right here, 138 times the base 10 logarithm of the quantity R2 over R1, where R2 is the inside radius of the outer conductor and R1 is the radius of the inner conductor. You can also use diameters, inside diameter here and outside diameter, or conductor diameter here, not including the insulation. Now, it's important that you have some insulation in this wire, and otherwise it will short out to the outer conductor when you bend the line or when this wire doesn't happen to run right down the center. You can find diameters for various gauges, AWG, in various publications. You can find it online. I would recommend that you use heavy gauge wires such as number 10 or number 12, solid copper insulated electrical wire. And for this, you use the largest copper tubing that you can get your hands on, and it can be pretty hard to work with. But I can assure you that if you get large diameter line, like a copper tubing 1.25 inches in diameter, it's going to cost you an arm and a leg per foot. But if you run this stuff and make sure that it's sealed and stays dry and condensation stays out of it, and if you don't run too much power, you should, at least in theory, get the equivalent in terms of low loss characteristics of open wire line, except a lower impedance, probably on the order of 100 ohms or less, 75 to 100 ohms probably. But as with open wire line, you should have no real problem with a high standing wave ratio, as long as you don't run so much power that you get arcing through the insulation to the outer conductor. And therein lies the problem. You're going to have this huge diameter hard line. It looks like it would handle 10,000 watts, but it will handle nowhere near that much because this conductor will wander around inside. The interesting thing is that it doesn't matter whether or not this conductor is centered. If it strays off center, the average position or the effective position of this conductor, when averaged out over the whole diameter, turns out to be just the same as if it were in the center, so it can wander around inside. Old automotive antennas, and I think maybe still some, use a coaxial cable that's sort of like this, except the insulation is on the inside, the dielectric, a thin layer of dielectric on the inside of the outer conductor, and then a piece of bare wire running down inside it, but it's only used for receiving, so you don't need to worry about power. There are various other ways that you can get spacing in line like this without using a solid foam dielectric and ending up with, in effect, conventional hard line. I've often thought that those little plastic golf balls with the little holes in them, they're about the same diameter as a regular golf ball. you get the inside diameter of this to be fairly close to or a little larger than the diameter of a golf ball, and then periodically, well, you could actually run them one right up against the other and just run this inside wire through the holes in the golf balls, trying to trying to get the wire to run through the center of the golf balls as much as possible, and just stack them up, and you'd have pretty much all air inside, and then you'd have spacers, which would allow for some bending of the line and keep the center conductor pretty much in the center of the line. You'd still want it to be insulated, though. And then you could run, say, a ground plane antenna with a very high standing wave ratio, and because of the fact that this dielectric is air, it should have the same advantages as an air open wire parallel wire transmission line would have with a balanced antenna. I've just wondered, have any of you ever done this? Have any of you ever built a line like this and run it with a high standing wave ratio and tested the results? I will confess that I have done it over just a short span. When I had an automatic antenna tuner at some distance from the antenna, and I used about 10 feet of this stuff, and then ran the antenna as a ground plane without worrying about the standing wave ratio. I sealed off the inside of this stuff very, very nicely by sealing both ends with caulking, that silicone caulking, after putting a few of those little packets inside that contain, I believe it's some compound that it's in a little bag that keeps things dry and keeps condensation from occurring, and the sealant would keep the bugs out, the spiders and the other little critters that could get in there and change the losses, and how, besides getting fried. But I just wonder if any of you ever tried open hardline and run it with a high standing wave ratio, say a 40 meter ground plane antenna, and tried to run it on 30 meters. And what results did you get if you tried it? Question and answer session open. Stan Gibilisco, proprietor and operator of amateur radio station W1GV Whiskey 1 Good Vibrations, saying 73, which means best regards in ham radio jargon, and so long, which, in my native fist, shall forever after mean da-da-da-da-da-da.